States of matter. In this lesson, we will look at how we describe a solid. Specifically in that area, we will talk about particles in a solid, types of solids, and then we will go on and talk about how we describe a liquid, and we'll talk about particles in liquids and properties of liquids, and then finally in this lesson we will talk about how gases are described. And in that section we will talk about volume, pressure, and temperature. So how do we describe a solid? Solid has a definite shape, it has a definite volume. Brick is an example of that. A solid keeps its shape and volume in any position in any container. So if we were to take a brick and put it in a 5-gallon bucket, it would remain the shape that it is. Particles in a solid. The particles that make up a solid are packed very close together. Each particle is tightly fixed in one position. A fixed, closely packed arrangement of particles in a solid cause it to have a definite shape and a definite volume. Particles inside of a solid can move, but they don't move very much. They basically just vibrate back and forth in position. Because of the vibration, solids are good at transferring energy as sound or electricity. That's the reason why we use copper in our electrical lines. They transfer electricity very well, but the atoms that make up copper don't necessarily move to a new position. They just kind of vibrate back and forth in position. So solids. The particles that make up a solid are packed very close together, remember. On this picture we want to mark whether a solid has a definite or indefinite shape, and does it have a definite or indefinite volume. And from the last slide we know that it has a definite shape and it has a definite volume. Types of solids. In many solids the particles form a regular repeating pattern. When a regular repeating pattern occurs in that solid we call it a crystal. Solids that are made up of crystals are called crystalline solids. So some examples here, some crystals that are found in nature. Please be aware that crystals typically have some type of shape to them that is regularly repeating. So examples of crystalline solids include table salt, sugar, and snow. And when crystalline solids are heated, they melt at a distinct temperature. So thinking of ice for an example, ice is a crystalline solid, and it has a point, a temperature in which it melts. That temperature is 32 degrees Fahrenheit or 0 degrees Celsius. Amorphous solids are the other type of solids. The particles are not arranged in a regular pattern. Unlike a crystalline solid, an amorphous solid does not melt at a distinct temperature. Instead, it becomes softer and softer, or it can change into another substance as well. Glass is an example of an amorphous solid. So glass blowers, they can heat glass up and it doesn't completely melt. It basically just gets softer and softer. Plastics and rubber are other examples of amorphous solids. Plastics is one thing that we produce a lot of, and if they would melt, then we would not be able to create the different shapes that we create with plastics. So a Venn diagram. Use the Venn diagram to compare the characteristics of amorphous and crystalline solids. So an amorphous solid. The particles do not form a regular pattern. It does not melt at a distinct temperature. Particles form a regular repeating pattern in crystalline solids, and they melt at a distinct temperature. The relationship between the two. They both have definite shape and definite volume because they are both solids. So how do we describe liquids? A liquid has a definite volume, but it does not have a definite shape. If we take a liquid and we dump it into a new container, it spreads out and it takes on the shape of that new container. If we don't dump it into a container, then it just simply spreads out into a shallow puddle. So we can take the same volume of liquid, add it to a number of different containers, and that volume of liquid will just take on the shape of the container. Particles in a liquid. The particles in a liquid are packed almost as closely together as those in solids. However, the particles can actually move around one another. So you can compare the movements of and the way that you might move a group of marbles inside of your hand. So if you had a handful of marbles, you take those marbles, you can kind of move them back and forth and around one another. That would be the perfect example of the way that the atoms inside of a liquid or the particles inside of a liquid work. They move back and forth and around one another. They touch one another, but they're able to slide around one another. So because of this, and because the particles are free to move, a liquid has no definite shape, but it does have a definite volume. The freely moving particles allow for liquid to flow from place to place. For this reason, a liquid is also called a fluid, which means substance that flows. So liquids. Liquids take on the shape of its container, but its volume does not change. So we need to know, does it have a definite shape or indefinite shape? Does it have a definite volume or an indefinite volume? Its shape is indefinite. We can dump it into different objects and it'll retain the shape of that object that it is in. Its volume is definite. We don't change the volume of a liquid. Properties of liquids. One characteristic property of liquids is surface tension. Surface tension is an inward force or pull among the molecules in a liquid that brings the molecules on the surface closer together. This allows droplets to form with many liquids, especially water, for example, because those water molecules are attracted real strong to one another. The attractions cause the molecules at water's surface to be pulled tightly toward the water molecules beneath its surface. Due to surface tension, the surface of water can act like a sort of skin. So, for example, if we were to take a sewing needle and we were to put that sewing needle on the surface of a liquid of water, it will actually float there. If we push it down, then it will sink. But you can see in this picture right here where the needle is actually floating on the surface of that water. Surface tension lets insects called water striders walk on the calm surface of a pond as well. Another characteristic property of liquids is viscosity. Viscosity is the resistance to flow that a substance has. So a liquid's viscosity depends on the size and shape of its particles and the attractions between them. So we've got two different substances here in this picture. You'll notice one is flowing faster than the other one. Some liquids flow more easily than others. Liquids with high viscosity flow slowly. Honey is an example of a liquid with a very high viscosity. Liquids with low viscosity flow quickly. So water and vinegar have relatively low viscosities. Hence the reason that the Gatorade douse tends to work. If water had the viscosity of honey, the coach would be able to move out of the way pretty quickly. So how do we describe a gas? Like a liquid, a gas is a fluid. Unlike a liquid, however, a gas has neither a definite shape nor a definite volume. So the particles in gases can move all over. And they can spread out and fill the container that they are in. If you could see the particles that make up a gas, you would see them moving in all directions. As gas particles move, they spread apart, filling all the space available. Thus, a gas has neither definite shape nor definite volume. So, onto our pictures again. A gas takes the volume and the shape of the container that it is in. So does it have definite or indefinite shape? Does it have definite or indefinite volume? It has indefinite shape and it has indefinite volume. Volume of liquids. Volume of gases. Volume is the amount of space that matter fills. Volume is measured in cubic centimeters, cubic meters, milliliters, liters, and other units as well. Because gas particles move and fill all of the space available, the volume of a gas is the same as the volume of its container. So the gases that are inside of our classroom, they are taking on the same volume of the classroom. Helium, perfect example. We pack helium inside of gas tanks. Helium, when it is released, expands to fill the balloon, and then because the density of helium is less than the density of air, those helium balloons will actually float. When we use helium to fill a balloon, it expands to fill many balloons that have a total volume much greater than the volume of the tank itself. So taking all of those balloons and filling them up, they would take on a much greater volume than the tank itself that they originally started in. Pressure. Gas particles constantly collide with one another and with the walls of their container. As a result, the gas pushes on the walls of the container. The pressure of the gas is the force of its outward push divided by the area of the walls of the container. Pressure is measured in units of pascals or kilopascals. In the American system, we measure in PSIs. Pressure equals force over area, so it is the force over a given area. The firmness of a gas-filled object comes from the pressure of the gas. So thinking of our rocket lab, as we increase pressure inside of those 2-liter bottles, there is a greater force over a smaller area. And that pressure needs to be released, and so when we do release that pressure, we end up with thrust, we end up with upward movement. Another example is the air inside of an inflated ball. The pressure inside of the ball is greater than the air outside of the ball, or the pressure outside of the ball, therefore it retains its shape and it becomes fairly hard. So this higher pressure is due to the greater concentration of gas particles inside the ball than in the surrounding air. And concentration is the number of gas particles in a given unit of volume. Higher pressure inside of a ball results in gas particles hitting the inner surface of the ball more often. This causes the ball to stay inflated. Because of this, even a small hole in the ball will allow a larger amount of particles to come in contact with the hole inside the ball than particles outside the ball. So the same thing worked with our rocket lab. Therefore, many particles go out versus ones that come in. So our rocket lab, when we remove the pin, that rocket takes off because more particles are shooting out of the bottom or the base of that rocket than are actually coming into the rocket. So the force of that water or those other particles that are coming out causes an upward momentum or causes upward thrust. The pressure inside drops until it is equal to the pressure outside. And when we get to the point with our rocket lab where we have equal pressure inside and outside, the rocket no longer has thrust. Temperature. Recall that as air is heated, it becomes less dense and rises. So hot air balloons are a perfect example of that. As hot air balloons, the air inside the balloon is heated, that air becomes less dense, it rises, causing the balloon itself to rise. A propane burner is used to heat air. That air rises and fills the balloon itself. Recall that all particles of matter are moving. Temperature is a measure of the average energy of random motion of particles. So the faster the particles are moving, the greater their energy and the higher the temperature. So in essence, you can think of a thermometer as a speedometer for particles. The warmer the temperature, the more particles are coming in contact with that thermometer, and the higher up the liquid is going to go inside of the thermometer. Even at room temperature, the average speed of particles of gas are extremely fast. At about 20 degrees Celsius, the particles in a typical gas travel about 500 meters per second. That is more than twice the cruising speed of a jet plane. So that's some pretty fast particles. So temperature of a gas. Why do hot gas particles move faster than cold gas particles? Faster moving hot gas particles are going to move that way because of the energy that's supplied to them. The warmer a substance is, the more active those particles are going to be.